Welcome to the Explainer. So today, we're going to unpack this paradox that's sitting right at the heart of modern AI. And trust me, it's a really fascinating one.
Okay, so let's just dive right in. You've got these digital AIs that can literally dream up entire movies from just a text prompt, right? But then you look at our physical robots and they can barely pick up a coffee cup without messing it up. So what is going on here? What's causing this bizarre disconnect between these, superhuman AI minds and these super clumsy bodies of our robots? Well, the answer? It's changing everything we thought we knew about building intelligent machines.
So the story really starts with the main approach we've been using for years now. And it basically treats robots like reflex agents. They're machines that react, but they don't really understand.
And this is called the Vision Language Action Model, or VLA for short. It's a really powerful system, and it learns by imitation. It watches millions and millions of examples of a task being done just right, and then it just connects what it sees to what it's supposed to do next. It's basically pattern matching, just on a massive, massive scale.
A great way to think about this is like the System 1 part of our own brains. It's that fast, intuitive, almost gut-feeling kind of thinking. Like when you catch a ball, you're not sitting there calculating the physics, right? You just react. That is what a VLA is. It's a high-tech reflex engine.
Okay, now this slide is really interesting because it shows you the VLA's double-edged sword so clearly. On the one hand, its big strength is something called semantic generalization. Because it's trained on all that internet data, it can pick up a SpongeBob toy it's never actually seen in real life just because it gets the idea of SpongeBob. But, and this is a big but, its weakness is physical novelty. So let's say you train it to push a block on a wooden table. Then you put that same block on a sheet of ice. It completely fails. Why? Because it has no internal concept of friction. All it knows is the statistical pattern it saw in its training data. You change the physics, even slightly, and the robot is totally lost.
And that critical flaw, well, it's sparked a full-blown revolution in robotics. It's forcing researchers to build a whole new kind of AI, one that doesn't just act, but actually stops and imagines first.
So say hello to the world model. This thing is a completely different beast. Instead of just reacting, it builds a little mini physics engine inside its own neural network. It's basically an internal simulator that's constantly learning the cause and effect rules of the physical world.
And this table just lays it all out perfectly. The VLA, that's our fast, reflexive System 1 brain. But the generative world model, or GWM, that's our slow, deliberate System 2. It doesn't just react, it predicts. It doesn't just generalize to new objects, it generalizes to new physics. It's the fundamental difference between raw instinct and actual reason.
So how does this thing actually work? Well, a robot with a world model can basically play out these little mini-movies of the future right inside its own head. First, it observes the scene as it is right now. Then it imagines a bunch of different outcomes. What if I push it this way? Or what if I try to lift it from that angle? And only after it's imagined all the consequences does it pick the best path and then, finally, execute the action.
Right, and this is the crucial point. A VLA, just acting on instinct, might blindly knock over a priceless vase because that's what the pattern told it to do. A world model, on the other hand, would simulate that future, see the vase falling, recognize that's a bad outcome, and stop itself. This ability to predict the future, that is the absolute foundation for creating robots that are safe and truly physically intelligent.
Okay, so how are people actually building this stuff? This isn't just theory anymore. Researchers are actively creating these AI imaginations, and they're taking two really different, really fascinating approaches. The first group, they're teaching robots to dream in pixels.
The whole idea here is pretty intuitive, right? If an AI can generate a totally realistic video of what's about to happen next, kind of like those crazy generative video models like Sora, then it must, on some level, really understand the underlying physics of the world.
And this leads us to models like Unisim. Now, instead of engineers trying to hand-code a perfect simulation of reality, which is practically impossible, Unisim just learns the simulation directly from watching videos. This is a game changer because it lets a robot practice new skills inside its own generated dream world. It turns this static library of old videos into an infinite interactive training ground.
But, generating photorealistic video is incredibly slow, and it eats up a ton of computing power. So this has led to a completely different school of thought, one that basically says dreaming in pixels is a total waste of time.
This camp, and it's heavily influenced by thinkers like Yann LeCun over at Meta, they argue that a robot doesn't need to predict every single tiny pixel. Does it really matter what the exact texture of the wallpaper is? Of course not. The robot only needs to understand the abstract concepts, the relationships that are actually relevant to the task at hand.
And that's how we get models like VJEPA. Instead of trying to generate the missing pixels in a video, it just tries to predict an abstract description of what should be there. It's a compact set of data called an embedding. By focusing only on this core information, it learns the essential physics of a scene way more efficiently. This means it can plan much faster because it's not wasting energy rendering all those irrelevant details.
Now, despite all this incredible progress, in both Pixel Dreamers and Concept Dreamers, there is one massive hurdle that's holding these imagining robots back from, really taking over our factories and our homes.
Speed. It all comes down to speed. Right now, these advanced world models run at less than 5 Hz. That means they can generate fewer than 5 thoughts or frames per second. Now, to put that in perspective, a smoothly controlled robot needs to make decisions at 20, 50, even 100 Hz. Thinking 5 times a second? That's just way too slow for the real world.
So the future, it seems, isn't about choosing one or the other, the fast reflex robot or the slow imagining one. It's about building a single complete mind that actually combines the best of both worlds.
The ultimate goal here is a two-part brain. You've got the fast cortex, that's the VLA model, and it's handling all the high-speed intuitive movements. It just knows how to grasp a cup. But when it runs into something new, something weird, maybe the cup is slippery or it's a really odd shape, it calls on the slow frontal lobe, which is the world model. This part kicks in, asks what if, simulates a few different options, and then sends guidance back down to the fast system. It's the perfect combination, reflex guided by reason.
So at the end of the day, here's what we're left with. This shift from simple imitation to genuine imagination, it isn't just some technical upgrade. It's the beginning of a truly new kind of intelligence. For the last decade, we've been focused on building the eyes and the hands of our machines. Now, we're finally building the imagination. And that leaves us with a pretty profound question to think about. What happens when a robot's imagination becomes even better than our own?